Hello everyone, welcome to a new video. In this video, I would like to deploy a FastAPI application to AWS. I have never built a FastAPI application before, so let's build a sample app together and deploy it into AWS. So FastAPI is a Python framework to develop APIs, super fast, very popular. Let's look into the documentation just a bit and let's see if we can create a sample FastAPI application. So let's search here, installation. So this is the idea. So basically you install FastAPI as using pip and then either one of these Uvicorn or Hypercorn. So let's create a sample application. The sample is already here. I have Python 3 already installed. So Python 3. Yeah, I have Python 3.9, so any 3-point version should be enough. First of all, let's create a virtual environment so that the dependencies won't mess with our system Python packages. So Python 3 -m venv project. So I have a project directory, project FastAPI. FastAPI. So yeah, there are some stuff here. Let's source this directory. Source bin/activate. Yeah. Now you have FastAPI. So let's install pip. Let's install FastAPI. Pip install FastAPI. All right. Python is already talking about availability, but let's ignore that for now and let's copy this stuff from the documentation. So let's create a new directory, mkdir src, and then code. So let's open this directory in Visual Studio Code. So you can see that it's already all these are from our Python venv package, but really we don't need to worry about much. So I have the src directory here, so maybe if you want to keep a venv in a different directory, this is also possible. Src, so let's create main.py and then paste it here. All right, so let's start to run this. So the terminal here already picks up my FastAPI virtual environment, and then it says run the server with Uvicorn main app reload. Okay, so let's install Uvicorn as well. So let's copy this from here, pip install Uvicorn standard, boom boom boom. So we have FastAPI in place, and then let's copy the command from here to run Uvicorn main app reload. All right, so it's already picking up stuff. So also to imagine we are always in this directory. Let's see if there is something going on. Error loading, I could not import module main. I think it's because our file is inside the src directory, and then cd src and then Uvicorn main app reload. This should also work. Okay, so this is our API. It works in port, it runs in port 8000, and so it returns for the root URL, it returns a hello world, and for items URL it just returns something. So let's see, items, boom boom boom. Yeah, it does return some kind of messages, errors. So we have this API working, and in the next video let's see how we can deploy it. All right, welcome back. Now let's look into deploying our application to an AWS EC2 server. So I'm in the AWS console. So also keep in mind that I'm in the Europe, Ireland region. Just to make sure that whichever region that you are in, you keep using it, or depends on your application. If it is something that needs to be served in the US, choose a US region. Otherwise, whichever is near to you will be faster. All right, let's spin up an EC2 server. So in the search, type in EC2, virtual servers in the cloud. Let's come inside the instances and create an instance. Say first API is, just give it a name, first API demo. Let me do it, demo. And then choose a Linux. I'm going to choose Ubuntu 22.4 LTS, which is the latest one. Yeah, let's use this. It's also free tier. Everything is free tier. We are using free. Yeah, a small server. And let's create a new SSH pair. If you would like to know what an SSH pair is, yeah, just Google it. I'm giving it first API demo. Yeah, let's not give it a space. Yeah, let's give it the name first API demo, everything keeping it default, PEM file, create key pair. Yeah, now you have your key file, now you have your PEM file downloaded. Make sure you save it somewhere else. You are not going to get it again. Once you lose it, you're going to lose access to your server. If you need it again, the only option you will have is to destroy the server and create something new. We need to allow access to our servers. Okay, the new console has these functionalities, allow SSH traffic. So for now, let's keep it anywhere, or maybe you can keep it, you can select this my IP option to only allow SSH traffic from your PC. For now, I'm going to allow it from anywhere. But yeah, you can also choose your IP. This is more secure. Now we need to allow HTTPS traffic and HTTP traffic. Let's allow both, and let's continue. Storage 8 GB. Okay, let's free to connect to 3. Yeah, let's keep it default and then launch an instance. All right. Now let us wait for the instance to be ready. Yes, you can see it as running. Please click a refresh button. Yeah, it just takes a minute or two. And yeah, let's see, it has a public IPv address. And yeah, let's see what the server has to, let's see if the server is responding to any internet requests. It says it cannot be reached, probably because it has nothing inside of the system. Now let's try to log into the server from our terminal. So it's simple. Let me clear the terminal. Let's log into the server. For this, you need the PEM file, which is in our downloads folder. For now, I'm going to move it into the project directory. Yeah, so I just copied this PEM file here. Make sure you never commit your PEM file in your Git repository or anything. People can scavenge it and attack your systems. But yeah, just for the purpose, you can see the stuff. I'm just copying it here. Now let's try to connect. For this, we need the public IP address, which is this one. Or you can even copy this. You can copy this IPv4 DNS. But yeah, this should be more than enough. Now let's open the terminal. Let me zoom in a bit so that you can easily see things. All right. I'm going to type in SSH -i, and then you pass in the PEM file, which is first API demo.pem. And then you type in root at the IP address that we have copied. Then it says something, yes, and yeah, it says permission is too open. So what we need is we need to use a 400 permission. You can Google a bit more about the permissions of the certificate. We are not going to go deep into the certificate permissions, but just as the warning message says, it is required that the private keys are not accessible by others. So we need to use a 400 permission. For this, you use chmod 400 fastapi demo.pem, and then issue the command again. Please log in as the user Ubuntu rather than the user root. All right, let's do it. Ubuntu. Yes, we are into the server. First of all, let's replicate our local setup, or let's set up a project inside the server, which is very simple. You can copy with a git clone or any other kind of process. Let's do that quickly. All right, I just set up this project. Yeah, you can see inside our src there is the main.py, which is exactly as our source code here, and then a git ignore file and a requirements, which lists basically our Fastapi and Uvicorn, all these dependencies. We do not commit any kind of VN, virtual env, or the actual packages which are listed here, and this we will install it in the production server. Let's go back to the terminal here, and let's see what we have already. Which Python, no Python 3. There is Python 3.10, which is more than enough. And let's see if we have git. Yeah, there is also git, and yeah, we should be good to go. Now let's set up the project inside the home directory for now. Let's clone the repository first. So here is Fastapi deployment demo. I can leave the link in the description. You can practice for copying, and it's a public repository. So yeah, let's copy this and let's clone it here. Yeah, and let's see, it's inside here, and let's just rename to Fastapi because I just don't want to type the full path every time. mv Fastapi. Yeah, now we have the Fastapi directory. Let's go inside. Let's create a virtual environment first so that our application can run. So pip3 install -r requirements txt. Oh, it says pip3 not found. Let's see if there is pip is also not found. Yeah, it says so. Yeah, you can install pip3 with this. Let's install pip3. First of all, let's do a server update. This is something that we missed. Let's do an upgrade. All right, everything looks like to be in order, and let's try to install pip again. Yeah, this time it works. Yes, run some processes. Looks like everything is in order. Now let's create a virtual environment so that our application can install the dependencies in that virtual environment, like we did in our local system before. Python 3 -m. So we are saying use the module with the m flag, which is venv, and then pass in the directory name. So let me create it in a new directory right now. It's called env. Yeah, so it says, yeah, again, we need the venv package. So let's install that. So sudo, yes. So venv module is now installed. Let's try this again. All right, looks like it has been successfully executed. Let's see, --la. Now you can see this new directory that has got created, env. So that's now we just need to activate this env using source env bin activate. Yeah, you can see with the env, this is the env that we are in, and now let's install the dependencies for our application. So pip3 install -r one final time. Wow, looks everything got installed. Now let's try to start our application with the previous command that we were using in our local system. So let's go back to the documentation to see it once again. It says Uvicorn main app reload. So let's see, Uvicorn main app reload. Could not, yeah, like it says, could not import module. Let's see src main. All right, so this works. So src.main. So this is a syntax that Uvicorn expects. So src is our directory, and inside that the main module or the main.py file. Reload. So it's running on 8000. That means if we go to the public DNS here and then port 8000, we should be able to see. But there are more complications in the way, because first of all, we do not allow port 8000 to be accessed from the AWS security group. And more than that, yeah, we don't want our application to be running in port 8000 in a production server. Let's say we just want it to be on port 80. Also, it's listening to the IP address, which is 127, which is the local host. That's also not what we want. We want to run it on the external IP address, which is 0.0.0. Yeah, let's look into these steps one by one. Right now, you can see it's port running on 8000, and our application cannot be reached 8000. There are two reasons. First of all, AWS security group don't allow access to port 8000. Let's fix that first. This is the first step. Let's go to instances here, and then you can see the security. You can see only port 80, 280 and 443 are allowed, and this is configured in this security group. Let's go to we are inside the security group now, and then click on inbound rules, and then let's click on this edit inbound rules, add a new rule, port 8000, and allow from anywhere, and save changes. Now let's try to refresh again. You still don't see it. What might be the reason? It is very simple. Here you can see Uvicorn is running on 127.0.0.01 and port 8000, which is not what we want, because this is a local host address, and what we want to listen to is an external IP address. So let's see how we can specify a host. Usually host 0.0.0.0. Yeah, port 8000. And it's already responded. Now you can see in port 8000 our application is running, and already we get a response. And let's see items /1. Yeah, you already get some stuff here. Q. Let's pass in Q equal to boom. Yeah, so whatever we pass in the query parameter here, it's already responding. Let me zoom in also to make sure that you see it well. Yeah, so right now our application is inside the AWS. It's also working. It's not a complete solution yet, because as soon as we close the terminal, the application would shut down. Now I clicked on refresh. You cannot see anything anymore. So to have it again, you have to start it, and then you have to click on reload. Yeah, the application is live again. What we want is like a daemonized process, meaning that we need to run this process in the background without any kind of problems. And also, Uvicorn in itself is not a great solution to serve your API. For this, we need something like Nginx to handle the incoming request. And using Nginx, you can configure your application to serve, like say for example, static assets such as fav icons and some CSS files, maybe if you are running a full stack application. But yeah, in the end, we made it work. In the next video, we will see how to make Uvicorn run in the background using something called Process Manager. Hey everyone, welcome back to the Fast API deployment to the AWS series. Until the last video, we have made our application running inside an EC2 server with Uvicorn. And the problem was that like whenever we close the terminal, we stop the process. Yeah, of course, our web server is no more accessible. Now in this video, we are going to take a look into how to make it a persistent process so that it always runs in the background. Now, there are many ways to achieve this requirement. One of it is to use something called a systemd, which is a process manager, and many other things as well. And there are so many process managers available to use. One of them is Supervisor, another one is Circus, and yeah, some more. So what these process managers does is that they always make sure that a number of processes that we say, okay, say for example, I want 4 Uvicorn processes to be run all the time. So whenever a process goes down, this process manager will restart it, so that yeah, we don't have to keep our terminal open all the time. It will do it for us. And one of my favorite tool is something called Supervisor. I use it all the time, and I'm planning to show it with Supervisor in this video. And before we go forward, let's also take a look into this Uvicorn. And now what Uvicorn is. Now Uvicorn is a software that implements the ASCII server pattern. Now ASCII stands for Asynchronous Server Gateway Interface. And previously, one of the common mechanism was a WSGI server software, which stands for Web Server Gateway Interface. And say, for example, if you use Django or those kind of applications, you would always see something called WSGI. So Uvicorn is an ASCII implementation, and Gunicorn with a G is a WSGI implementation. But this Gunicorn has more options compared to Uvicorn. Even though Uvicorn is somewhat new, it doesn't have all the capabilities of Gunicorn. Now, from the Fastapi documentation, you could see that even some of their recommendations include running Fastapi with Gunicorn process manager or interface. But instead of doing that, let's stick to the Uvicorn. Instead of introducing tools on top of tools, let's stick to what we have already, and let's try to make it work with Supervisor. Let's install Supervisor. You have to issue this command sudo supervisor. Yeah, with this you should be able to see Supervisor CTL. Yeah, you need permissions, of course. Sudo supervisor is running as a root and searching for, okay, we already have Supervisor D. Now let's create a configuration file for Supervisor, so that the supervisor can read this configuration file and run our Uvicorn application. And for this, yeah, maybe you can already see that there is no configuration inside this directory. Now all the supervisor configurations are inside conf.d directory. Before we build up the supervisor configuration, let us write a small script to start our application with one simple command, so that we don't have to really mangle between the local path and the path in the server. Whatever command that we write, and we just put it in a script. That's all. So let's come back to our source code here, and let me write a new file, start.sh. So this is a shell script. It's nothing complicated. So let's begin. Let's add our shebang line /bin bash or bin sh. Yeah, both works. Whenever this script is executing, we want to come to the directory where the start.sh file is, where the file is present. So there is, I'm copy pasting something here. Yeah, you basically get cd into the current directory. So let's see this example here. If you can, I'm just zooming it a little bit here. Right now I'm in the Fastapi directory, so you can see I'm here. Say for example, if I execute start, we have to give it executable permission. So let's do chmod u+x start.sh. So it's nothing complicated. So let's come back to terminal. You can see I'm in the Fastapi project. So let me switch to home directory. I want to execute this start script, which is inside the project Fastapi start.sh. Execute this. You can see this line. This comes from this echo statement here. It basically prints out the current directories, because we switch to this directory wherever our code is. It just got switched to here. The paths that we write in this script, say for example Uvicorn. So Uvicorn sits inside the env directory, which is our virtual environment. Remember, I just moved our env directory to a new path here. So when I say env bin something, it will only make sense if we are in the same directory. So that's why when the script starts, the script basically move the execution to that appropriate directory. And then let's see what else. And we just want to activate the virtual environment, env bin activate. If we don't do the switch, if we don't do the cd, what is going to happen is like we will have to type in like /home / blah blah blah. But the thing is, like, this script will be different between the server and the local. So that's why we have the customization here. And then what we want to do is like we want to trigger the Uvicorn ASCII server. Uvicorn src main. So our main, the py file is inside the src directory. You can see here src main.py, and then :app. We have to do a little bit more configuration here. You can see this in the Uvicorn's documentation. Then host, and host equal to 0.0.0 because we want to listen to external connections. Write in workers. Now I'm writing it for, I'm keeping it for. So usually like there is a formula for finding the number of workers that your server can have. But yeah, for now you can, depends on whatever server that you choose, you can input this number. We need to have this number in our mind because we need to use it again. Yeah, so this is the simple script. So let's see, let's try to execute this. Project Fastapi start sh. Yeah, you can see application startup complete. So yeah, accept. And now you can see because of the number of workers 4, you can see the like 4 startups, and you can see these are like 4 process IDs. This is our start script. Let me commit it and let's pull it in the server. Right, now it's pushed. And then let's go to our server, which is already here, and do a git pull. One file changed. So let's do an ls. And then you can see our start.sh is already here. Now let's try to execute it. So we just want to make sure the script is working all right. Start.sh. Yeah, it started for 1, 2, 3, 4. 4 processes have been started. Yeah, it's listening. We can also try to reach the website. Yeah, it's here. Yeah, it's already working. You can see that yeah, the server is responding here. Now we want to run this start script with supervisor. For this, let's go to the supervisor configuration directory and add a configuration. And the configurations are inside the directory called /etc. So let's go there, /etc, and then supervisor conf.d. And this is a directory that a supervisor will look into whenever it starts or stops. So let's come here. Let's do an ls here. Yeah, there are some log files and stuff. Now let's create our configuration file. You need, of course, sudo touch first api demo.conf. And then let's edit this file. I left the links to this file in the description. You can copy it or you can type it along with me. First API, also you need sudo to edit this file. So first of all, we need to add a title. Let's add the title, which is typing program Uvicorn. Yeah, it's just a name. Supervisor looks into a socket here. Localhost 8000, which is our port. And then command. This is the command that we need to run using supervisor, which is inside /home/ubuntu/ fastapi /start.sh. Yeah, I just remember this path because it's in our home directory, fastapi, and simply start.sh. And then we have to add num procs. This should be equivalent to the number of workers that you have specified inside the start script. You can see behind here workers equals to 4. So how many workers we have, that many processes we need. And then give it a name, process name, so that you will see it in the logs what is going on, or which process is failing, stopping, starting, etc. So first API Uvicorn. Yeah, give it some descriptive name. And then you can see process num. So this is a parameter, so that you will see first API Uvicorn process 1, process 2. So it's like just a number and with a D. Okay, process name, and then std out log file. Now we want to see the access logs and also the error logs. So in case if something goes wrong, we can look into the log file and see, okay, what went wrong with our application. Because once we close our terminal, supervisor is the one who keeps running, and in case of any logs, the logs files are stored here. So you can keep this logs within your application or outside the application or in a temporary location, but I like to keep it here, var log supervisor, and then Fastapi access.log, and then I'm copying the same line and then pasting it here, and then simply changing it to td error. Whatever is returned to the standard error, we want to see it in the Fastapi error.log. I'm going to yeah, we need some more configure parameters here. One is auto start equal to true, auto restart equals to true, and then stop as group equals to true, signal quit. This is a configuration to really kill the process so that we don't have dangling processes that still occupy the port. While I was testing it, whenever I issue like a restart or something, the supervisor process could not really connect to it because the port was being occupied. You can actually experiment with some of these options just to, to make it work, just to make sure that your this path and the port and the number process is correct, and also the path here. And let's save this. And now we have to tell the supervisor to read the configuration and start all the process. Now let's see if the supervisor main process is running. So sudo service supervisor status. You can see that the main supervisor service is running, and let's see if we can tell the supervisor control to read our new configuration. So ctl reread. Wow, it says Uvicorn available. Tell him to update, added process group, and then let's see sudo supervisor ctl status. Wow, you can see according to our pattern that we gave inside the configuration, you can see it's created like 4 processes with 4 IDs. Fastapi, Uvicorn 1, 2, and 3. Now you can see it's running in the background. You can also see its uptime, so it doesn't stop, so it clearly works. Let's refresh our website once again. Wow, you can see that it works. In case if you are stuck somewhere, it doesn't give you the right messages, gives you some error messages, the first thing that you have to look is at the status, and within the status you will be able to see, okay, if it is failed or running. So usually you will see some kind of error messages. Another place that you will have to look at is the log. So let's look at our configuration file once again. Let's see supervisor conf.d fastapi demo.conf, and you can see that we have given this std out log file and std error log file. So in case of any errors, you will see it in this file. So you can see cat -n, and you can see that this is an info messages. So let's see if we can make some error and show you the obvious one. Let's edit our fastapi/start.sh, and we are making some edits to create some errors here. Restart all. Let's look into the log file now. You can see that this error is coming inside the log file. Even though status shows us running, you can see, okay, it doesn't work because something going on. So you can really come to this var/log/supervisor fastapi error log, and then you should be able to see what is going on. Let's fix the file again. sh uvicorn src.main/app-host workers. So there is this supervisor ctl restart all command. It's all started, and then you should be seeing your things. Okay, so far we have reached a point where we deployed our application. It's working in the background, and so your application, the API is working. One last thing which we have to do now is to put our application behind Nginx, which is also a reverse proxy and a load balancer. Definitely you can go with Uvicorn, but Nginx on the other hand is much more powerful. The default settings are much more safe and secure. For all of this, we have to talk a little bit about the security of our application. Now, if you see, all our applications are owned by the user called Ubuntu. It's all owned by Ubuntu, which is a user which has the sudo permissions. We don't want to run our applications as this user. Instead, we want to run this application as a user with very less privileges. We will take a look into the file permissions in the next part of the video, and then we will take a look into how to set up Nginx. Hey everyone, welcome back to the series of deploying Fastapi into cloud. So far we have created the application, put it in a AWS EC2 instance, installed Supervisor and configured it to run in the background. In this video, we are going to tackle a little bit of user management so that our application is a little bit more secure. So if you haven't subscribed to my channel yet, please subscribe. I will be posting more videos like this often. Let's continue. As you can see, currently, all our files are owned by the user, which is called Ubuntu. Now, Ubuntu is a root user. Now, we don't want our files to be owned by or executed by a root user. What we want to do is to create or use an existing user. One such user, which we can use, is called www.data. So to see all the current users in a system, you can execute this command. cut-d, yeah, you can copy it. It's this command here, cut-d. Yeah, it basically lists the lines inside the etc/password. And there are a lot of users, including our user Ubuntu, and then there is the root. And what we are interested in a user called www.data. Most commonly, servers like Nginx, Apache, all of them are using this www.data user. It is nothing particular. It's just that conventionally web servers are using this user. We also would like to use, it's not a root user. That's the most important part. Now let us edit the supervisor configuration and change the user so that our start script is being triggered by this www.data user. Let's see /supervisor conf.d Fastapi demo. You can add the configuration here as which user you can run. So www.data group www.data. Save this. You can use this supervisor ctl update command. You will see stopped and updated the process group. Reread. I am not entirely sure what is the difference between these two. Let's see the status. You can see, okay, it's already like a fatal here. Let's see the error message. Child could not execute Fastapi e-access. So probably looks like a permission error. Definitely looks like a permission error. Yeah, of course it's obvious. -la. You can see this Fastapi is owned by Ubuntu, and of course Ubuntu is a root user and www.data is not a root user. And of course the non-root user cannot execute or anything on the files which are owned by Ubuntu. So what we need to do is to issue a command which is called chown, sudo chown www.data, which is the user, and www.data. So we are changing the user and the group of the project of all the files recursively from Fastapi directory. Now let's see ls-la. Now you can see this Fastapi, this is owned by www.data. Let's go inside Fastapi. ls-la. You can see it's all owned by www.data. Now let's restart the supervisor ctl update. Let's do an update and a restart all. Okay, there is still error. Of course, the Fastapi, this directory is now owned by www.data, but the thing is, like, this directory sits inside the home directory of Ubuntu, which is only accessible to Ubuntu. So even though the Fastapi is accessible by www.data, because it is inside the home directory, you cannot really access it with the www.data user. Now the solution is that we move this directory to another location, which is common for almost all the web applications, which is inside /var/www. So let's do cp or mv. Let's do that. First API /var triple W. Now ls minus LE. Yeah, you don't see the file here, but slash triple W. Okay, so it just moved it to or with 4 W's. So let's see mv www slash fast API. Of course, k there minus p sudo. So we create this triple W directory. All right, now let's go inside the triple W directory. Ls minus LA. Here you can see that the fast API directory is owned by triple W data, whereas triple W, the folder itself, is not owned by triple W data. So let us fix it. /var/triple W. So what we are doing is like we are completely owning all the files and directories inside the triple W folder to this user. And with these things should take place, but still we have problem. We have to change the start script location of the configuration. Std out, you can see now it's no more home/ubuntu, rather var/ww/fastapi start sh. So that should do the trick at least. Let's do an update command. Restart all. We are still getting error. Let's take a look into the logs. Okay, now it says command not found. It's line 5, command not found. Let's look at the start script once again. I mean, now the permission issues are almost gone. Cat start.sh. Let's see if we can manually start it. Okay, Uvicorn command not found. cd env. So the problem was that when you move the directory, you also have to recreate the virtual env. And this is what I'm doing here after some random checks. I basically deleted the existing env directory and then recreated a new one. Now activate the env, of course, csv source and then activate. Okay, and now install -r require txt. I'm not very confident that we need the sudo here, but like let's see, it should install everything. Then let's see start. Okay, success. So this really starts. Restart all. Okay, so now that works. So basically you had to reinstall the env virtual env. That was the idea. Now let's come here. Yeah, everything works as expected. Let's try something new. Yeah, it's there. Tem id 234. Yeah, so it works. Let's see the status. Yeah, it all works. It all works fine. All right. So that's all about this video about changing the user. You can see that now our application is completely owned by the user called www data. A little bit of changes. First of all, we changed the configurations inside the supervisor configuration, and then we move the file to var/ww and change the permissions, and then reinstall the virtual env. Yeah, that's it about the video. And in the next video we will see how we can set it up with Nginx. Hello everyone, welcome back to our Fast API deployment series. This is going to be our last video in this series. We are finally going to put our application behind a reverse proxy, which is Nginx. Right now you can see our application is running in a port which is in port 8000, and we want to put it behind port 80. We also want Nginx in front of it. Let's install Nginx. Sudo apt install Nginx. Yes. Let's see if the Nginx service has been started. Sudo service Nginx status. You can see that it's active and running. Now let's copy the domain here, and you should see the welcome to Nginx, so the default page, the famous default page. Now we want to tell Nginx that whatever request comes to you, please go and use the Fast API to look it up and then serve the user. For this, we of course need an Nginx configuration. Let's create it. As usual, all our configurations are inside the /etc/nginx directory. Let's go there, cd/etc/nginx, and then there is sites available and sites enabled. So this is the default one, and let's create one which is inside the sites available folder. Touch, you can see it's all owned by root. So let's create this new file, touch first api.conf. Of course you need sudo, and then let's edit this file, first api.conf. For this we can go to the Uvicorn's deployment documentation, and then you on the bottom you can see the running behind Nginx. So you can see why and like what are the benefits of using such a thing. So let's copy this stuff here. Let's not think too much. Let's copy this thing, and I pasted it here. And then there are these things, server name example.com. So you have to replace it with our domain here. Yeah, so you don't need the HTTP or anything, any of those stuff. So if you have a domain configured, of course you can use this domain name here. One thing that we have to look for is this proxy pass. And you can see it's like http/uvicorn, and then you will see this Uvicorn. So whatever is written here is referred here. So what I was saying is like pass this as a proxy to here, and here it's a server, it's UNIX, and this UNIX it's a UNIX socket, and it's basically a file. It's a socket, it's a file, and it's inside the temporary directory. So what we have to think about is like this location. So when a request comes in, our application is going to look for this configuration, and from this configuration it sees that it has to go through Uvicorn here, and it's going to look into this. It's going to look into this UNIX socket, and then read the information from this socket or communicate with this socket, and yeah, return the response back. So let's save this. You can see that we have saved our configuration inside sites available directory, but this configuration will only be active when this is inside the sites enabled directory. To do that, we use a technique called symlink. You can also create this file inside the sites enabled directly, but it is better to have it inside the sites available and then use a symlink. So you can see ls-la sites enabled. Okay, so we are inside of this. Come out. You can see that this is a symlink from the default to sites available default. Yeah, so let's do the same thing. So ln-s, also of course you need sudo ln-s /etc nginx sites available /fastapi conf to /etc nginx sites enabled. So let's see this thing again. So you can see, okay, we have our new configuration present, and for this configuration to take effect, we have to restart Nginx. So service Nginx restart. Probably we are going to get some errors. Of course, the socket doesn't exist yet. Yeah, you can see it's already errored, and yeah, our site stopped responding. To fix it, yeah, remember the location of the file that we had, get enabled. It's here. Now within the Uvicorn documentation, you can see this parameter UDS. It's basically UNIX domain socket, bind to a UNIX domain socket. So let's go to our start script and fix it. And our start script now lives inside the war/w folder. You can find it all in the repository. All these configuration files will be there, so don't worry about it. Even if something is missing between these, or we are changing it between the videos, but you can find it in the repository. Let's go inside the www fastapi directory and vi start.sh. At this point, my recording somehow stopped working, but I have modified the start script to just have the parameter UDS because the workers and other parameters were causing some problems. You can see the modified file. So right now it has only Uvicorn and the UDS, so bind to the UNIX domain socket. With the file descriptor and the workers, it was causing problem. Let's see where does this lead us. But right now, if I do start.sh, you will see this error, but behind the scenes, supervisor is already running this script, and that's why we cannot use the same address. And that is the error that pops up here. Let us check how supervisor is doing. So the service supervisor status. You can see the main supervisor process is running. You can see all of this is running. All of these are running here. But our Nginx is also failing right now. You can see so the service Nginx status. You can see it is also failing, and the configuration test failed. Yeah. So let's see what are the failures on this case. Sudo nginx -t. HTTP directive is not allowed here. Okay, let's see. etc/nginx/sites. Here you can see this HTTP block that needs to be removed. Well, let's see, remove this. Let us save this now. Not okay. Now the error has changed. You should increase the server names hash bucket says 64. Now we have to edit the main Nginx configuration, not the custom configuration that we have made for our application. Yeah, we can see the server names hash bucket size 64, this line here, and let's increase it into a little bit bigger number, say 128. Let us save this configuration. Okay, it's okay, it's successful, everything looks good. Nginx restart. All right, wow. So guys, our application is now being run through Nginx. We can verify this. I'm opening the web developer tools, doing a refresh here. You can see server Nginx 1.1.8 Ubuntu. So right now it's being run through Nginx /items/23. Yeah, so it works obviously. Everything is good. All right, so I guess that's it. So we finally put it through Nginx. Hopefully we see you in another video. So please post your doubts, comments. If you need help, just comment it. Hopefully I can help you. Let's see you in another video.